Hey guys, welcome to video 2 on Latin squares. This is the presentation for March 24th, 2021. If you watched the earlier video, you know our topic's Latin squares. So in this video we'll be talking about counting Latin squares and some of its applications. So Latin squares for beginners. The basic definition of a Latin square of order n is an n by n grid filled with n symbols so that each symbol appears once in each row and column. This is pretty important for later. So you can make a Latin square out of symbols or numbers as long as n is the same throughout. An example of the previous statement is using the 4 suits of a card deck. So since there are 4 different suits in the card deck, we must orient them in a 4x4 matrix where each suit is unique to its row and column. So if you look at the picture right here, we have a heart, club, spade, and diamond. Just to check and see if it's true, there's not another heart that appears in this column, and there's not another heart that appears in this row. So it gives us a valid example of a order 4 Latin square. So there's different variations of Latin squares. Latin squares can be oriented in multiple different ways. An example of this would be a Latin square of order 4 can be oriented 4 different ways. A few example, or 3 of the 4 examples of order 4 Latin square. So you see 4 2 3 1, 2 1 3. All that, and then we look at the next example, and by swapping the rows, or not the rows, the columns, we were able to make a Latin square with the same symbol, the same number of symbols, and orient them in a different way to where it holds true. So just to check this, we have a row, or a 1 in row 1, column 1. We look down the column, there's not another 1 in this row. Look at the row, and there's not another 1 in this row. And then moving forward, we could do the same thing by changing the rows around. So here we changed row 3 to row 2 and row 2 to row 3. And we'll just double check this one more time. So there's a 2 in column 2, or row 2, column 1. We look across, 2 3 4 1, there's not another 2 here. We look down the column, 1 2 3 4, and there's not another 2 there. So these are just a couple of different variations of Latin squares. So how do we count Latin squares? The good news is that there's a formula to count n number of Latin squares for when n is small. So the general formula that is used to calculate the number of Latin squares is n of n and n, and that equals n factorial multiplied by n minus 1 factorial multiplied by Rn. So what does Rn stand for? Rn is the number of reduced Latin squares, and n stands for the order of Latin squares. So let's just get into a brief example to try and get a visual for this. So let's say we wanted to find the number of Latin squares with order n equals 5, and there's 56 reduced Latin squares of order 5. So if we plug 5 into the formula, we get 5 factorial multiplied by 4 factorial multiplied by 56. We get 161,280 as the number of possible Latin squares. To compute a problem like this, it requires access to a table of reduced Latin squares, as there is no specific formula to find the number of these other than counting. So here's the table of reduced Latin squares. We'll just go with a brief example. We used order 5 in the previous examples. So for 5, we could see that there's 56 total reduced Latin squares, and in the third column, it's just all the different mathematicians that attributed to this. As we can see, the number gets astronomically high as n starts getting higher. So we look at a number like 11, we get this massive number, and it's not something that can be done. It's simply not something that can be done by hand. It was done by computers. Moving forward, here's a table of the currently known Latin squares. Um, as of right now, we only know up to order 11, uh, and we can see why just by looking at these numbers here. As soon as we get past order, I mean, even order 6 is pretty big, 812 million, but going forward to order 7, that's 61 trillion 479 billion 419 million 904,000. That's just an absurd number, and it gets very large. So what are some other facts about Latin squares? As mentioned earlier, currently we only know the number of Latin squares up to n equals 11. After 11, the formula has been proven not to work anymore, and the number is astronomically high, so we can't use normal counting techniques to help us out here. Latin squares can also be split into n isotopy classes. What isotopic Latin squares are when you take two Latin squares, and when you put them next to one another, one can be obtained by the other by permuting the rows and columns and symbols. And these isotopic classes have also been studied extensively and are known up to n equals 11. And then just getting into some quick applications of Latin squares. We often see Latin squares from the classic game Sudoku. I'm sure everybody knows what Sudoku is. It's very popular puzzle game where you have to fill in empty squares using deductive logic from the game's rules. The main difference between a Latin square and Sudoku is not only do the rows and the columns have to be unique, the diagonal also needs to be unique as well. So, yeah. And then another application of Latin squares is in error correcting codes. These error correcting codes are in sets of orthogonal Latin squares, and have been seen useful when communication is disturbed by types of noise that aren't simple white noise. And a third application of Latin squares are they're often used in statistics, and they are the basis for the Cayley tables of quasi-groups. If you've taken linear algebra, you know what that is, because it is a part of the multiplicative property, and it's just a binary operation whose table of values forms a Latin square. So, guys, this has been my presentation on Latin squares. Very interesting topic. They're very unique in the sense that they are used in different ways, and like how much they relate to things like Sudoku and other real life things, and they have some very interesting applications. If you have any questions, feel free to email me at roushd@go.stockton.edu. And that's my presentation. Thanks, guys.